All right. What is up, everybody? Welcome to another episode of Tom McGurl's Stream. Today, we're going to be doing something with Rust. You all love Rust. We're going to be back at it. We're going to be making a request today with Rust to an API that I've created. And we're going to be using the request library. That's Request. So that's a library for making HTTP requests with Rust. Now, we haven't done this before. We've talked about it a few times, but I'm excited to get started. First things first, to call something out, I just wanted to give a shout out. We've recently hit over 1,000 subscribers on the YouTube channel. So if you're watching on YouTube, thank you so much. It's been a real pleasure. We've had some return visitors that I really need to shout out. First off, got to give a shout out to Mr. Big, the one and only Mr. Big. I'm not talking about the character from Sex and the City. I'm talking about Mr. Big. If you've watched the videos, you've seen him in the comments. Mr. Big has been going through every video, keeping us posted on his progress. So shout out to Mr. Big. Awesome to see you in there. Thank you so much. It's people like you and comments like you that keep me going. Super excited to continue. Another shout out goes to Daniel Cashel, another one in the chat, going through the videos. We also have Steel String, another return viewer, been leaving some great comments. And then if you've been joining the live stream on Twitch, we took a break. We took a little 6-month break hiatus when I had a baby, new dad. But a return visitor, always in the chat, always bringing the positive vibes, and the author of the theme that we are using in VS Code. I got to give a shout out to Greyjack. Check out Greyjack's theme. I'll put a link to it in the chat. I'll put a link to it in the show notes. But Greyjack's theme is what we'll be using today, and he's been returning to the stream, giving awesome tips, helping me through. And actually what we're doing today, I originally did as a live stream. I kind of struggled through it, had some issues with getting M variables to work and things like that. It was a little rusty, right, on the Rust. Little Rust puns. Come on. You're here for the puns, right? Greyjack helped me through it. So today we're going to be redoing that exclusively for YouTube for this one. I'm not streaming it because, again, I already did the stream of that. If you do want to check that out, if you want to see me struggle through it, go to twitch.tv/TomMcGurl. And I'll be picking up the live stream again Tuesdays. We'll be doing 9 p.m. to 11 p.m. So expect that to pick up again next week. Next week being November, right? So I think we'll be at November 2nd will be the next episode. But today we're going to be jumping back into Rust. But as usual, got to give the shout outs. Check out the YouTube. Look we broke 1,000 subscribers. So thank you so much again for all the viewers. One thing to note, today we're going to be using an API that I built using Supabase. It's a backend as a service, an API as a service. It allowed me to upload some data, and it gives me a REST API. If you want to see how I created the API that we'll be using today, check out this last video, getting started with Supabase as a backend. Definitely worth watching if you're looking to spin up a quick backend, and it's, again, what we'll be using today. We'll go over it briefly. I'm not going to cover it all because, again, it's covered in this video, but that's what we'll be using today for our API. Again, follow on Twitter if you want to get updates for when I go live. Just got to give a shout out to this time last year, we did a Halloween theme stream. We'll probably be doing something like that soon too for the holidays. So that was fun. But yeah, check out the Twitter where we have all that stuff happening. And you get some live updates. Today what we're going to be doing is we're using the request library. So the request library is a Rust library, again, for making HTTP requests. We're going to make a request to an API that I built using Supabase. So here's Supabase. Again, if you want the overview, check out the video where we go through creating exactly what I'll be using today. But so Supabase, I've preloaded it with some data. I just made that data from a Google Sheet, imported it here. And what's cool about Supabase is it gives us a little API. So the API we're going to be working with today is going to be the REST API that Supabase generated. And now you'll probably see my keys and my secrets. That's okay. They're going to be deleted before this video is posted, so don't worry about that. But yeah, we're basically going to be using the API that's generated for us, which we can actually test out with curl. So I'll do that really quick. I'm going to just show you what that API looks like. Just a basic REST API. Again, what I'm querying here are some data about beers. So I picked beers. We have an ID, a name, a style, brewery name, and a rating. We'll go into that when we build our struct on the Rust side. We'll build a struct to represent this that we'll deserialize. But to start out, just let's look at the API we're going to be using. So what I want is this API here for reading all the rows. So it gives you this nice commands where I can just copy them. I'm going to copy the curl command, and I'll just run that to show you what that's going to look like. So if I curl this, again, it's my Supabase URL /res/v1/brews, which is the table that I'm querying. And then I'm just selecting all the rows. So if I hit enter, you'll see we get back data. So this is what we're going to want to request with our Rust application. We're going to request this data. We're going to serialize it, which means we're going to take it, convert it from a string to something in Rust we can actually use, and then we'll print out those values and get some experience using the request framework. We're also going to load up our secret keys and our API key through a .env file. So it'll be get ignored. It'll be a file that's get ignored, so we won't commit it to the repo, but we'll be able to actually read that file and use that to make our request. And we'll also be using something called serde for deserializing the values. And again, deserializing means taking this from a string and converting it into something, a type or a struct that we can use in Rust. So first things first, what we're going to do is we're going to create new projects. We're going to do cargo new. We'll call it Brews. You can see I already have that there. And we're going to go cd into Brews. And we'll just open that up in VS Code. And so once that's opened up, there we go. I'll pull that over here. Okay, so now we have our Brews. And again, we used cargo, so you can see it generated at our cargo.toml. Our source code with our main, we're not going to make a library here. We'll just use a regular main here. And it still looks like it's generating our target, debug. And you can see our main, it always starts with a hello world. And again, the theme I'm using today, shout out again to Greyjack. This is Greyjack's theme. If you want to see what that looks like, go to color theme. We got Monokai Greyjack. We got Pastel. A bunch of different ones. You can see Tokyo Night Greyjack. Ooh, we might have to use this one. This one's pretty sweet. But yeah, check it out. Greyjack theme. We got One Dark Greyjack. Ooh, there's so many good ones. I think I'm going to use, let's see. Let's search Greyjack. We're going to go with, Nord is pretty nice, but I think what we're going to do is we're going to go with Tokyo Night Greyjack for today. Let's try it out. All right, so what we're going to be doing, again, is making a request. So the first thing we want to do is just run this project to make sure everything's good. We're going to do cargo run. It's going to build. Okay, all is good. We have our hello world. We're good to go. All right, next up, what we're going to do is I'm going to create a .m.example. And this is something I will commit to the repo. Basically, this is so that someone can pull down the code and have a clue as to what they have to put for their .env. And this is just going to be an example file. It won't hold any values right now. But let's just do Brews API key. And we'll just set that equal, we'll just say, you know, for whoever's reading this repo, we'll say set that equal to your API key, right? And then we'll do Brews. I think the other thing that we're using is the, let me go to my here. So we have our service key, we have our API key and our token. So we'll do Brews API token. And then we'll just specify that here's where you should put your API token. Well, I can't type. There we go. Let me move this out of the way. All right, so now we have our example. And again, this file is just for an example for anyone that wants to create one. But now let's create the actual .env. So we'll do .env. We'll just copy that example over. So we'll just do this here. Go over here. Paste that. And now we'll put the actual values. But first, let's make sure that we get ignore this file. And so now if I do get status, you can see that .env is not being included. If I do get status -s, you can see that the env example is included, but my .env isn't. And that's what we want, because in the .env file, I'm actually going to put my actual tokens. So to get my tokens, I can just copy them from here. Here's my API key. Again, don't worry about this. It will no longer be valid. I'm going to delete it after we are done today. So let's just go ahead and paste this here. And I don't think, yeah, that should be good. And then here, I'm also going to paste my API token, which again, I can get from here. Awesome. Paste that there. I'm going to save that. Okay, so now we have the .env file set up. It has our keys. And again, the reason we put them here is so that we don't have to commit it to the repo. We don't want to share these keys, right? So these will live here, and we'll see how to pull that into our Rust application in a second. But next, what we're going to do is we're going to go over here to our request library, which is what we're going to be using. And so this is what we're going to be using to make an HTTP request. So you can see the request crate provides a convenient higher level HTTP client. That's going to allow us to make requests. And that's exactly what we need. We need to make a request to our URL. So you can see here, making a GET request. For a single request, you can use the GET shortcut method. Now we're going to need to be doing a few extra things. If you notice here in our Supabase curl that's outlined here, we actually need to include some headers. One of the headers is API key. The other one is authorization. So we're going to need to use a version of request, that lets us actually send the headers. So one thing we can do is actually go to the request crate homepage where there's some examples. Let's go search for that. There's the actual page here. And here you can have some examples. And so you can see there's two ways to do requests with the request library. There's the blocking client, meaning it's synchronous, meaning it makes a request, waits for the response, and then continues execution. Or we can do the asynchronous one, which is when you will make a request and you'll get a response asynchronously. Now you'll notice there's a few differences here. So the asynchronous one uses something called Tokio, which allows us to do that asynchronous behavior that we want. So if we look at what Tokio is, just really quick, we don't need to go into too much detail. Maybe we'll visit this in another video. But Tokio is a way to build reliable network applications without compromising speed. So it's going to let us build reliable, fast applications, and in this case, do things in asynchronous manner. If you're familiar with JavaScript, you've probably used asynchronous. All the requests we make, right, with fetch, if you use async await or promises or futures with Python, anytime we're using something that will eventually be fulfilled in an asynchronous way, like futures or promises, you're dealing with asynchronous code. And so that's what we'll do today. We'll actually use this version to try to make our request. So first things first, what we're going to do is we're going to add our dependencies. And we'll do that to our TOML, right? So we're going to add request and Tokio. So I'm just going to copy this. I'm going to go right over to my repo here. We're going to go down to our cargo.toml. Again, TOML, Tom's obvious markup language, Tom. Come on. No brainer for me to use this, right? So we have request and Tokio. Okay, next, it has an example of some of the actual code that we will need to run. Now, we don't need to pull in this at the moment. We're probably going to deserialize this stuff ourselves in a second. So what we'll do is, let me just move this here. What we'll do is we will pull in this part to start out. We're just going to pull in this basic stuff and replace our code here. So let's go to our main. We're going to replace this. And let's just kind of go over what's happening here. So first off, we're declaring that this main is going to be using Tokio. And you may notice there's something different already. We have an async func main. So we're declaring that this main is asynchronous, meaning it's not blocking. It'll make the request and it'll just give us the response when it's ready. The other thing you may want to note is that we've changed the return type from being just the unit type to being a result over the unit type or a wrapper. Remember, we learned about box, right? A box around error, and that's because it can throw a few different errors. So we're just saying generically, we're either going to have a result of the unit type, meaning we'll return nothing, or we'll capture an error. Because of course our API request could fail. So capturing errors is going to be key right here. Okay, so let me just make myself a little larger there. All right, so let me zoom in here too, because this is super small, probably impossible to read, right? So there we go. Let's look at this again. We have our result, box error, a request. This isn't the URL we're going to be using, so we're going to change this a little bit. Okay, so first thing first, we'll try to make a request, and we'll actually need to have our API keys. So again, we're going to need to pull in from that .env file that I wrote. And so the way we can do that is with a library called .env. So it's a crate called .env, and this is what we can use. And it's pretty straightforward. We pull in the library .env, and then we use .env OK, and it loads the values from our .env, and it puts them into our environment variables. So let's go ahead and try this out. First things first, of course, we have to add it as a dependency to our cargo.toml. So let me look at where an example of that is. Let's go to the actual docs. Let's see. Let's go to GitHub. All right. It looks like .env. That we don't need to use the macro, so let me just see where to import it. So it looks like we can just do, let me pull this up here. Just pull in the latest version, which is 0.15. So we'll just pull that in right into our .env. So what we'll do is we'll go back here. We will go to our .env. We have our main, cargo toml. I'm going to just pull in that version right here. All right. So now we have .env. And of course, we need to install these. So when we run brew run, or cargo run in this case, it'll actually install those. So we'll run cargo run. So it's going to install the dependencies needed for Tokio, request, and .env, and probably won't run anything because remember we just copied that request code. So let's go back to our code here. Let that finish installing. You can see here in Tokio, you can see the different requirements that Tokio has. So these crates themselves have pull in a bunch of requirements. We have hyper being pulled in, and you can see serde JSON here. That's the thing that's used for deserializing. We'll be using that as well. And I don't think we need to declare that as a dependency because I'm pretty sure since Tokio pulls it in, we'll just be able to use that directly. But if not, we'll just pull it in. We'll see what happens. So, all right, so our hello world still runs. Let's go back because we didn't save. Let's save this. Okay, so now what we're going to do is we're going to pull in .env because we're going to try to pull in from that env file. So let me go back to where we have it here. So we're going to do use.env, and we're going to just pull that right into our thing here. So let's do use.env. And then again, you can see the next thing we have to do is just call .env.ok, and that's going to load our .env. So we'll do that right in our main here. Oop. .env.ok. All right, so this is complaining. That's just because we have to do that. Okay, so we'll get to this part in a second, why it's complaining. It's complaining right now because it can't find hash map. We can import that. Hash map comes from the standard library, and that's just under standard, I believe, collections, and then hash map. Cool. What does it say here? Semicolon. Duh. Okay, so now we have .env, we have hash map, we're loading our .env. Now the next step is going to be to actually leverage the values from that .env. And so the way that that works is they get put into env, like the standard env. So we can pull in the standard env as well. That's the standard environment variables. You may remember us using that. I believe it was in like chapter 2, or maybe we used it when we did the book for our grep. But either way, we're going to pull in standard env. And now we're going to try to pull those values out. Now, to pull those values out, we simply just ask for env and then the key. And we know what the key is because it's the key from our .env file. So we can do let API key equal, and we can just do env, and then we're going to use var because we want to get a particular actual env variable, and then we're going to give it the key, and the key here is going to be one of these keys. So our API key is this. We'll just copy that, put that there, and then we want the token, API token, and then again the token is just this. Copy that, paste that there. And again, just to repeat, the reason we're using a .env and not just hard coding these is because we want to commit this. I want to share this with all of you, but I do not want to share my API key and my token. Again, doing it for the video, but by the time this gets posted, that'll all be gone. So good luck. Good luck. Also, you may notice the new sign, hack. Shout out to my company, Electric AI, for handing that out to us for our Hack Week projects. Awesome swag we got for a hackathon we did. You might see some of that stuff. I was able to use Elixir for the hackathon. It was pretty cool. Might be bringing that to the stream as well in the future. Okay, so anyway, now we have our API token. And now what we need to do is change a few things here. So first off, we can't use just the standard request.get, and that's because we need to provide headers. So we're gonna have to change this a bit, and I'll show you how I figured that out. Let me go back to request. So here's the .get. Here's client. So the client is what we're going to use because the client lets us declare the method. So we do client.get, but then it's going to actually let us set the body, let us have send and await. But actually, there's also a function here we can call called headers, and headers is going to let us set those headers. Now, the way headers works is headers is a hash map. Why is it a hash map? Because it's a map of key value pairs. The authorization with the bearer token, API key with the API key. So we'll create a new headers hash map. We'll populate that headers hash map with the actual keys. And then what we'll do is we'll pass that to our response client. So the first thing, again, we're going to want to do is populate that headers hash map. So here's what we're going to do. We're going to go back to our code and create that headers hash map first. So we're going to make a mutable hash map. We'll do it after this. How are you all liking the theme? Hopefully you like it. So here we're going to say headers equals, and we're going to do a header map. So sorry, not a hash map. We're actually going to use header map from request header. It's going to pull it right in because that's the type of thing that we need to pass to headers. And we're going to say new. We're not going to populate it yet. We're just going to keep it right there. And now we're going to try to insert the headers that we have, the API key and the API token. Now header map expects, well, you can see right here. Header map expects a header value and a key, and it knows the different types of possible keys for headers. For example, it knows one of the headers is authorization. That's a very common header. So what we can do is we can try inserting it. So we can do headers, and it's a header map, so we can do insert. And the key here, you can see it's giving us a hint here. Inserts a key value pair into the map, right? And the value should be a header value. So the key we're going to use here is authorization. That's the name of the authorization header. So if I start typing authorization, capital A, and let's just for funsies just put nothing, we'll see that this is unknown. But what we can do is we can actually pull in the appropriate key that header map expects. So we can actually pull that in from our request headers. So here we're pulling in header map. We can actually also pull in some header keys. So what I can do is I can try to figure out what the header key is for authorization. So first I'm going to do this, and then I'm going to say, okay, what keys do we have? Let's see what other imports we have, and we'll use autocomplete to figure it out. So here are some examples. Let's see, is API key in here? So API key is not, but is authorization. Good. All right, authorization's there, so I'll just use this to be safe. So we'll say key equals authorization. And then the value is going to be, well, the value here is actually going to be the API token, but we need to preface it with bearer because we're using a bearer token. Let me show you what I mean by that. If you take a look here, if you look at our curl, the authorization header needs to be prefaced with the word bearer because we're dealing with a bearer token, like a JWT token, right? So we're going to preface that with bearer. So to do that, we're just going to format a string. So what we'll do is we'll say authorization equals, and again, we can use the format macro, and we're going to pass it bearer. And then if you remember, for formatting a string, we're basically going to do this here. And then we're going to pass it the API token. Save that. And let's see, it's complaining. It says expected a struct header value, but found a struct string. So we need to convert this string to a header value. Now, how do we do that? Well, we can use the parse function. The parse function can take a string and convert it to a different value. So to do that, we can use .parse, and let's take a look at what parse does. You may remember this from our previous examples. So parses the string slice into another type. Because parse is so general, it can cause problems with type inference. So we want to it what it needs. So in this case, it actually requires a header value. So we can specify that we want to parse this as a header value. And then of course, parse returns a result. So we need to unwrap to get that value. And if it fails, it'll throw the error, but if it's successful, it'll unwrap. It says also here API token. Let me make sure that's the right thing. API token. Yep. Let's see what it says. It says result string var error doesn't implement standard display. The trait display is not implemented on result string var error. In format strings, you may be able to use So what we can do there is we can change our thing. Hold on one second. Let's see what we can do here. So API, it's because of this. It's because mvar here doesn't return a regular string, it returns a result. We can deal with that by just simply using the question mark, right? I believe it's called turbofish. We can turbofish that to say, hey, if it fails, just let it fail. If it's good, just give us the string. And so now we actually do have the string. And now this is done complaining. It's like, okay, you have the string. We're parsing it to a header value and unwrap. Now, you may remember that when you parse, in Rust, parse can actually infer the type based on the previous function call. So because format is expecting a header value, we don't actually need to tell it that we want to parse it to a header value. So this aspect here is a little more declarative, but it's unnecessary. So we can actually get rid of that, and it's still going to be good. Okay, now we need to do the same thing for API key. Our key is going to be API key, again, because there wasn't any value in header value for API key. Oh, what is this complaining about? Header value is unused. Let's see, what does this say? Because we didn't make it mutable. Sorry about that. Make it mutable. And header value is not used. So because we removed that from parse, so we can get rid of that. Okay, so now we have headers, insert API key, and we're putting this here. So now our headers is complete. We are ready to use headers. Now we need to create that request client. And so again, I'm going to comment this out because we're not going to use this part of it. Instead, what we're going to do is we're going to create a client using the request library. So again, that's this. We're going to create a client just like this. So I'll copy this. So we have client request, client new. That's going to be a new client. And now we're basically going to use something similar to this. I can put this back now. But instead of request, we're going to use client. We're still going to use get, but we're just going to use .get because we have a client now. So we'll use .get. And the URL is going to be different. So the URL is going to be the URL of my Supabase here, which is going to be this. So we'll paste that here. That's my URL. And now we need to add the headers. So we're going to do .headers, and now we're going to pass it our headers. So it says request builder is not a feature. The trait feature is not applied for request builder. So let's take a look. So we have client here, .get, and we're passing it this list. And so right now it's saying that request builder headers. So request builder is not a feature. The trait feature is not implemented for request builder. Required pull. Add a set of headers to the existing ones on the request. The headers will be merged into an already. Okay. So we have headers. We have headers. Oh, .await. We need to do .send. That's why this got messed up. So we have .headers, and then what we want to do is send the request and await on that. So sorry, that was from the previous code. Basically, we have our GET request, we add our headers, we want to send it. This is going to have a future, and then we want to wait for the response. Then when we get the response, we simply want to log it down here, and that's what this log is going to do. Now, we're going to run into an issue. I'm going to run it, and I'm going to let us run into that issue so that we can solve it. And that issue is that we're not deserializing the response. What do I mean? Our response is going to come back as JSON. So we're going to get a response that's a future, but we're not actually going to get the values from it. And that's what we need to do, is actually get the values from it, which we'll do in a second. But for now, let's see where we're at with this. So let's clear this out, and let's do cargo run. So we have an unused import that it's telling us about. That's okay. That's great. We love Rust for doing that. So we will solve that really quick and then we'll come back. It also looks like API key isn't being used. And yep, that's right. Another good call out. So let's get rid of that unused import. We're not using the hash map. Now we're good. And let's take a look at what our response was. So in this case, we got a response, URL, cannot be a base, false, username, blank, host. We got a 401, which means forbidden because our API key was wrong. So let's try again now that we've changed it. All right, so we still got a 401. Let's see what we're actually sending. So we have our headers. These are the response headers. This is the response. Let's see if we can actually see the request headers. So let's take another look. So we have our API key. We have our token. We're formatting. It's because we don't need to format the API key. The API key doesn't need all that bearer stuff. So what we can do with API key is just use API key. So now our API key is just being sent plain. So if we want to compare that to make sure we're correct, API key should just be sent like this, and only authorization needs bearer in front. So let's try that out now. Cargo run. Let's first clear it out. Cargo run. It's building. Cool. There we go. We got a 200 response. That's what we're looking for. We got a 200 response. We're all good. But now, again, we don't have that response. So now we need to actually take the response JSON. Now, if you're familiar with JavaScript, right? I'm just going to write this down below here. If you're familiar with JavaScript, you're probably used to doing something like this. Maybe when you make a request, let's see if I can put it in comments, you do something like this. Const response equals fetch. You provide your URL. My endpoint com/get whatever. And then you're going to await on that because that returns a promise. And then you'd probably do something like this to get the actual JSON out. Response JSON equals await response.json. And that also returns a promise. So we need to do this step in Rust, actually getting the JSON out. And so what we're going to do for that is we're first going to have to, well, let's first try it and see what happens. So we're going to do let response JSON equal. And so what we're going to do is we're going to do the response because we have the access to the response and we can actually see what it is. The response is of type response, and that actually has a .json value. And that returns a future with output or a result, right? And because it returns a future, we can't just use this, right? We can't just use the turbofish because it's a future. It should complain. Let's see. Well, actually, it won't complain, but it'll return a future. We actually want the value, so just similar to JavaScript, we actually need to await on this to get the value out. But now let's check it out. It's saying oh, that's because of this. Let's move this up here. So our response JSON we have here, we're awaiting, getting the value. Let's try to print that and see what happens. Response JSON, and we'll type here response JSON. All right, we're gonna do cargo run. Error, request error, kind, decode, error, invalid type sequence, expected unit, line 1, column 0. So the problem here is we need to actually deserialize this value into something we can use in Rust. And so what are we dealing with here? Well, we're actually looking for a request with brews in it. And the reason that we do this deserialization, and you may be saying, hey, this isn't something we need to do in JavaScript, or this isn't something we do in Python necessarily, unless you're using some sort of serialization or validation. The reason we need to do it again is because Rust is very safe, right? It wants to make sure that the stuff we're getting back can be handled safely in our application. So we need to say, hey, we expect the response to look like this. And we need to tell the application to try to convert the response into this structure. And if you can't do that, well, then we can't work with it because we're going to lose the guarantees that we would have if we knew what the type of the object was. So, long story short, we need to create a structure to represent our response. And so if you look at what our response is, again, we can go back here and we can do our curl again. Let's do our curl. Let's see. There we go. We get a list, right? We're getting an array or a list of brews. And a brew has, or a beer has an ID, a name, a style, a brew name, and a rating. And we can represent that as a struct in Rust. So let's do that. So we'll declare it outside here. We'll declare a new struct. We'll call it brew. And if you remember how to declare structs, we're going to give it the properties. So let's name it. We'll put out the properties first, and then we'll put the types, style, and then we have brewery, name, and rating. So ID we know is just an integer, so we'll do integer 32. Our name is actually a string, right? Our style is also going to be a string. Brewery name, again, string. And our rating, again, will be an integer 32 because it's a numeric rating. Now you can see here, brew is not used, and that's okay. We're going to use it in a second. Now, we also want to be able to log this because down here we're trying to log it. So if you remember, we're going to have to add that here. I believe the syntax is similar to this. So we do something like hashtag derive. And then what we need here is debug. So we just do like that, I believe. Debug. All right. Now, the next thing we're going to have to do is deserialize this. So we have a struct. Now we need to tell our actual response JSON, hey, you need to convert this to a brew. We can try doing it here. We could say, okay, response JSON should be of type. We are going to do a list of brews. So we have a vector, right, of brews. So we can tell it that. Move this over here, right? And let's see what happens. So here we're saying JSON, and it's saying the trait bound brew serde deserialize is not satisfied. Required because of the requirements of the implementation for blah, 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 blah. Basically, it's saying if you look here, it says try to deserialize the response body as JSON. Here's some options. So it shows you right here what's going on. Here it's giving an example, trying to deserialize an IP. And this is why we love Rust, right? Look at this example. What is different about this? Well, the derive requires the serde dependency. Derive, deserialize. So let's copy that. And you can see here that it requires the serde dependency. So we're going to add this, and we'll see that we don't have access because we need to add that serde or serde dependency. So let's first add that here. And it's going to say, hey, can't find it. So that's because we need to pull it in. And again, it said that dependency, so we're going to search it, serde. And we're going to pull that in, and that's going to allow us to deserialize. It's a framework for serializing and deserializing Rust data structures. Perfect, efficiently and generically. You can see an example. Deserialize and serialize. So serializing is when you take a string and deserialize when you take a string, right, and convert it into, deserialize it into an object or a struct in this case. And serializing is the reverse direction. It's actually taking a structure and converting it into a string or something that can then be sent over the wire, right? So here, what we'll do is we'll add in serialize, and we'll have to import it. So if we look at how to actually add it, we can go to using derive, and it says here, add serde as a dependency to the cargo toml. So let's do that first. Cargo toml. Let's add that as a dependency. And then it says, so we did that, check. Ensure that all other serde-based dependencies are on a version that's compatible with serde 1. We don't have any others. On structs and enums that you want to deserialize or serialize, import the device macro. Use serde serialize. We're not going to use that. We're going to use deserialize. So that's the one we need. We need deserialize. So what we'll do is we'll pull that into our project. So we'll copy that. We'll go over to our Rust here, and we'll add that to the top. And now another cool thing is since we have derive twice, we can actually simplify this as we saw in the example. We could just do this. So we're pulling that in, deserialize, and then down here, our complaint is gone. And so again, here's what we're telling it. We're telling it to deserialize this as a vector of bruise. All right, let's give it a shot. Also, we can now change this to debug. So let's go ahead and see what this looks like and see if everything works. Ready? Let's run it. Let's go, fam. Let's see, come on. It's installing that serde dependency or serde. If anyone knows how to pronounce that, let me know. I'll have to look it up. All right, so it's building it, pulled in those dependencies. Come on, Bruce. Making the request. Bam, look at that. Again, what you're seeing here is the debug output, the printing debug output. So response JSON is an array of brews, and you can see it's prefaced with the struct, brew, 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 brew. So there we have it. We have all 5 of our brews coming back in our response. We did it. We made a request to the API. Let's, for fun, try changing this to request a single entity. So what we'll do is we'll select a particular brew. So if you go back to our information here and we go back to APIs, you can see we have read rows, filtering. So we can filter ID equals .1. So we'll do that. Let's add one. Let's add a filter here. So we'll do brews ID equals 1, and we'll select all the columns. Actually, let's do ID equals 3. So what we're expecting to get back here is this one, Pumpkinhead. Style Pumpkinhead by Shipyard. Appropriate for the time, right? It's appropriate. All right, so here, we're gonna see that this is actually going to, it might fail, right? If this doesn't return a vector, our deserialization won't work. So let's check it out. Let's see what happens. Okay, so in this case, it still does return a vector. So we're good. It actually still works. Response JSON, brew, and there we go. Pretty cool. Now what happens when we select a particular field, a subset? So let's just select, in this case, we're gonna select the name. Let's see what happens now. So it cannot deserialize it. And that's because it's telling us it's missing a few fields. And this is actually great because imagine if we made this request and expected the response to be a brew and we tried to work with it as if it was a brew, meaning we tried to get the name, we tried to get the rating, maybe we wanted an average of the ratings. That would be a problem. So Rust handles that up front by saying, hey, your response, it can't even be deserialized, right? It's not the right shape. And of course, we're throwing the error, and that's happening, right? Because we're wrapping this whole thing in an error. And again, we're using Turbofish to just basically try to unwrap it without actually catching it. But you could imagine we could put a match statement here and match on the error and check if there's an error and do some proper error handling, maybe re-request it or maybe not request it again. This is just for the purpose of the demonstration. We're turbofishing, so we're throwing the errors right up to the top and seeing what they are. But so that's pretty cool. So we know that, hey, you wouldn't actually get a full brew, so it's not going to allow that. So let's just go back to what we had with our select star, run it again, and see that we get a response. And then what we'll do to wrap up is we'll walk over the code that we just wrote, and we'll wrap it up. So there we go. Made a request to the API, got our brews, deserialized them. Let's take a quick run through of what we did today. We'll maybe throw some comments in, and we'll sum it all up. First things first, we pull in our .env. Again, that's because we want to store our environment variables in a file that is get ignored. For people using the repo, I've given an example, and I'd probably put in the documentation like, hey, you need to include your brew API key or your API token in the .env, and I would let them copy the .env example and modify it. I've added the .env to the get ignore, again, so that I don't commit it to the repo, so that all of you don't get my API keys. And we pull that in. The other thing that we pull in is our request library. We're pulling in two things, the authorization header, which I could have just provided a string, but I decided to pull in the type. But you see it worked with API key. So I also could have just put a string authorization here. And a header map, which is how we constructed our headers that we pass to our request. The other thing we pull in is our standard env. That's where the .env is going to load our environment variables. And serde for deserializing the actual response into a Rust struct, in this case, the brew struct. So here we declared our brew struct. Here we've set up our main function. Again, we're using Tokio, so it's an async main function, meaning it handles stuff asynchronously. We can use awaits within it, and we know that it deals with futures, right? The return type of our main is a result over the unit type or a box around the error. That's because we can throw many types of errors. So this is basically saying, hey, it's either going to return a union type or it's going to throw one of many types of errors. In our case, we had a deserialize error, right? We had a headers error. We saw a few. So that's what this is going to do. We're loading up our .env. So let's just put a comment there to say load.env file into env. We could even say into standard env, right? Here we're pulling out our API key and API token from our .env file. So we could say pull out token and key from env variables. Here we're going to construct our header map, and this is what we're going to use for our headers. So create a new header map to be used as request headers. Here we're going to populate that with our token and key. Populate header map. And then we'll even say here, we have to parse the string into a header value using parse, just so we're clear there. Here we're creating a new request client, sending that request client with our URL, adding our headers, and awaiting on the response. We're printing the response, and then here we are deserializing the response into a vector of brews. And then we're printing it. So that is basically it. So again, very different if you're coming from a language like JavaScript where you can just fetch and .json and await on that, especially with async await. Used to be a lot harder if you've all were pre-Ajax with jQuery, you were doing just the raw request. It was a lot harder. Now it's very easy with fetch. But the difference here is that you're getting that safe ecosystem that Rust provides. You can already see the things that it told us and complained about. You can see things like deserializing, the importance there, right? I'm sure any of you that have dealt with the scripting language like Python or Rust have made a request to an API, gotten back a response, and then tried to basically operate on that response, and maybe something was undefined or something was null and it threw a runtime exception or it threw an error. Rust is going to make sure that what you get back is what you expect, and that deserialization process is going to add that. Now we can do that in other languages, right? In TypeScript, for example, if you're using TypeScript with JavaScript, you can specify the type of a response and ensure that the response is of that type. In Python, right, we can add validations. You could use Marshmallow, you could use Pydantic and add some validations around the responses. But the cool thing about Rust is it's going to be built in right to that deserialization, and we can map it right to a struct. And we're going to still get that safety. We're still going to get that type safety that Rust provides. And the same thing goes for headers, right? It's making sure that your headers map is constructed of a header key and a header value. You can't just pass it anything, right? You have to say, hey, I'm passing a certain thing of this type. So pretty cool. A little bit of overhead with the deserialization. The .env is just, you're going to have that overhead no matter what you're doing, because if you don't want to have your API keys in your code, which you never do, right? You're going to need that. But overall, not very difficult. Pretty straightforward. I'm going to continue with this. I'm probably going to try to add to this and do some more stuff, but I'll definitely be making more HTTP requests with Rust in the future, so I'm glad I learned this. Hopefully this was useful for all of you. Just to recap, if you were curious about this, again, about the API that we used here, this was Supabase. You can see how to create that backend that we use today in this video here, getting started with Supabase. Check it out. It's awesome. It's a backend as a service. I just started using it. Really enjoy it for spinning up quick backends for stuff like this, or maybe you're doing a quick hackathon project, or even a real project. It seems like a legit solution, not sponsored by them or anything like that. I just really liked it. It's an alternative to Firebase, which I've used in the past, so check it out. Again, this is the request library that we used today. The other libraries we used today were Tokio, which was used by the request library, dotenv, and serde. I'll post those links in the notes. Follow on Twitter for updates for when we go live for the stream. Again, the stream is going to be Tuesdays, 9 p.m. to 11 p.m. We'll start that up again next week. But yeah, I hope you've enjoyed this. Check it out. It's going to be up on the channel with the other videos. If you like what you see, of course, like and subscribe. We've broke that 1,000 subs. Whew. And again, wanted to give one more shout out to Mr. Big, who's been following along. Daniel Cashel also following along. Greyjack for the amazing themes that he's been providing us in the Twitch stream and that we use today. So check out Greyjack's theme in VS Code. But yeah, that's pretty much it for today. Making requests with Rust. Hope you enjoyed it. Try it out yourself. Let me know what you think down below in the comments and have an awesome time. All right, catch you later.